splitting it maybe not making it. Already forget what but anyway, all right. So basically, remind you, this course is not just pass and fail. This has a grade. All right. Keep that in mind, right? So basically, the course distribution is actually gonna learn more techniques that if you think that what we learn on the pre-course is fast, it's gonna be faster. Right? Because on the pre-course one is actually the basic one. That's why it goes through. Right? So this one is just we're going to spend more time on the computer lab and just use the output. It's going to be less part that we have to calculate manually, but there will be lots of new parts that we have to read the output. All right? Okay. So basically, I mean, like the core description is like this, but it's just cover many things compared to the other program, YangX and this program is actually go slower. So maybe we might not be able to cover all these things, but try to see how much we can fit in 8 weeks, right? So so this is some kind of tentative thing, right? So second thing is that we're gonna have some kind of quiz, right? And we're also gonna have some kind of group presentation on the very last topic, and then we have the final exam. All right. In your syllabus, right? In your syllabus, you're gonna have some kind of link here, right? Link here, which is whatever we're gonna talk. Material we put in there. Okay. All right. 10% from class for this presentation. We have assignment. We have a quiz, which actually worth 45.5%, right? And the final exam is 25%, right? So the books still the same. So mainly, if you pay attention to the class, you just fine. Last time, I believe last time you haven't used textbook at all, right? I mean, my version is already the simplified one actually. All right. So maybe let's talk about this a little bit. Let's see. In the link also have the schedule, right? So this is the first week, right? The reason that I have to usually we have the class on Monday, right? But we have to have class on today because on the third week I'm not going to be around. So if we have the class next week and then skip, it's going to be a bad idea, right? So if we meet here today, right, and then we're going to meet in the computer lab like 3 times. So that we're going to learn how to use the software to make an output. Right? Because the goal for this class, the reason that before is in one big class, split 2 parts, so that this class is closer to how to make the output to do the IS, to do small research. Yes.
What software are we using?
SPSS mainly, but for IS you can use anything, doesn't matter. All right, but SPSS is actually the easier one for general people to follow. All right, but same old thing, like making output is not that difficult. Most of the time it's actually integrate and translate output. Okay, all right. I mean, if you don't know the concept, it's very hard to talk about what detail in the output mean. Right? Remember is that like it's not calculation; it's actually how we translate that into your research question. All right. So the detail about the rule, we just I think the PPT will actually tell you what the rule is. All right. So next time on Monday we meet on the computer. I'm still thinking like 1 or 2 questions, alright, but it's going to be a shorter one. Right? Shorter one, and it's going to be individuals because now it is 4th grade. Alright, or I mean, if you like only the final one, then it's fine for me. But keep in mind, if you have the smaller one, you know what's going to be in the final. Let's make a short one. But keep in mind, because like right now it's going to be just more like application, how we use that, most of the time it's going to be straightforward if you pay more attention to class. All right. So those are tentative. Right. So we meet 2 times, and then the third week I skip right because I'm not going to have to be discussion, and then I'll come back. And then we the 4th week we'll be having the quiz. All right. I think there's also a makeup on this week, usually Monday and then Wednesday. Same old thing, if it has happened that you have to miss that class, just make sure to let you know ahead of time, and then give me some kind of formal evidence, formal letter, right? Something like that. Okay, because if you miss more than 20%, you fail. That's a July rule. Okay, something like that. I think at the last week, the very last topic is going to be some kind of advanced one. So let's do have some kind of groups presentation. So that's something that you can share your risk, those kind of things. Okay, something like that. Right? So that. Okay. So let's see. So let's kind of review what we have learned from the pre-course. Okay? Alright. So, right, remember that what we learned from last time is basically just the first thing is that we learned about the point estimation. If you remember, right, when you deal with categorical data, right? By the way, I don't forget. Last time I told you that some point from the pre-course will translate to additional to 0.5%. I will keep that. Don't forget that. All right. I mean additional, not part of this class. It's to be on top of that. All right, just that. All right. So last time we talked about point estimation. When we deal with categorical data, you summarize to proportion or percent. All right. When you're dealing with quantitative, you summarize to shape, center value, the mean, and how spread they are, standard deviation. All right. So that's point estimation. You think of X bar, you think of PR. All right. And you also have the confidence estimation. If you remember, we have the confidence interval. All right. At the end, for this part, it's not going to be calculated by hand. All right. It should be in output. You think with output it's going to be easier. If you know what they are, it's going to be easy. But if you don't know what they are, it will be difficult. All right. So the interval we have lower bound, upper bound. At the end, if you remember, when you have the interval, you have to ask yourself that interval is for estimating what. All right. Any number within that range is a good value to estimate what that value that you want. At the end, it's just going to be the interval for the mean or interval for the portion, this kind of thing. All right. We also talk about confidence level. If you remember, the confidence interval comes with the confidence level. For example, 95%. 95% means that is the risk that to give a bad one, 5%. 90% that is the risk, 10% that we give a bad result. All right. And make sure you know how to use the interval. Right? You want to back up some claim. As long as that interval back up that claim, all the values in there back up that claim is a good claim with some confidence. That's an interval. All right. Hypothesis testing. Right. Hypothesis testing. First, you need to know what is the setup for H0 and HA. Now, hypothesis. The alternative hypothesis. In this class, there will be many kinds of hypotheses. Right, different tests. There are certain ways to set up H0 and HA. Right, and hypothesis also. The rule for hypothesis testing is basically at the end. What you need is that you need to get a p-value from an output. If you remember how to use the output, how to use the p-value. After you get the p-value and you know what kind of H0 and HA we have, if p-value is small, smaller or equal to significant level, then you reject H0. For all the tests, it's just that. You compare your p-value with the significant level. Most of the time, it's set to be 5%, but I can always change in the question. All right. When it's small, smaller or equal to alpha, then you reject H0, and then you translate reject 0. H0 means 1, something like that. All right. Significant level means the chance of making a type 1 errors. If you remember, we talked about type 1 errors, type 2 errors. So this is more one kind of risk. If you set this one to be 5%, there is a risk for having a type 1 error, 5%, this kind of thing. All right. So those are the main things that we learn. In detail, we learn to test. All right. We learn to test. You see, when you talk about the mean, we have one sample t-test. right? The name of the test, that's something you should remember. Because when you use the software, right, there will be many menus that you have to choose. If you don't know the name at all, it's going to be hard to use the software. All right. For the mean, we have a t-test. If you remember, t-test look kind of bell shape, similar to C. If you remember, I told you that T is more like approximate of C, something like that. All right. With degree freedom, this kind of thing. And this one is talking about the mean. So S0, the equal sign, put on S0. The rest, not equal sign, less than sign, greater than sign, then you put on HA depending on your research question. Alright? All the tests come with the condition. For t-test, at the end, t is about z. So at the end means that you want x bar to be about z, right? Meaning that you need x bar to go to normal. When they go to normal, first is you have to have random samples. Second would be the original population is normal or n is large. Why you guys give me the new face like alright, you remember x bar, right? X bar is the sum of x divided by n. Normal plus normal is normal. That's why x bar is normal when the population is normal. How do we check population is normal? Look at histogram. Look at QQ plot, if you remember. Alright? Or n is large, alright, sample size. Alright, on this side, right, when you talk about P, when you're dealing with categorical data, alright, your question will be about P, right? Now your question will be about P. So S0P compared to some number that you compare to. HA would be less than sign, greater than sign compared to P0. Alright, condition random sample, and you remember P estimate by P hat. Alright, so P hat go to normal when N is large by using this condition. Okay, so those are the whole thing. So I don't want to spend much time on the whole thing. That's the whole thing. All right. So let's see. Let's see, right? So I think today you have at least these 3 handouts, right? If you remember, this is something that we had before. So this is some old thing that we have talked about, but haven't talked about all of them. All right. So let's see. Example 1, right? Consider how much each employee salary should be raised. 40 employees are from A and 60 employees are from B. Evaluate and summarize 2 performance score. Okay? You remember, right? There are 2 groups of sample. Department A, Department B. All right. So maybe just click on into this page, right? See. The screen, right? So this one. So now we treat the score as some kind of quantitative. Alright, this is a histogram from Department A and Department B. Alright, so remember when you have quantitative, you summarize to 3 things. Shape. So this is skewed to the left, both of them. Right? And then maybe you talk about the center value. Right? You see that Department A seems kind of like on the right hand side more than on B. Right? Right hand side means more score, maybe imply that A and B perform better, but not so obvious in this picture. Alright. Also, you might talk about the spread. You see that they are somewhat similar. This one is more a little bit spreader. Alright, that's in terms of this graph. You see that it's not clear. There is a little bit trend that A might do better, alright, but not so obvious. Alright, so from that part, alright. Also from this part, you can also mention that maybe this one may not be from normal because the sample doesn't look exactly normal. You see, it's skewed to the left. Alright, same thing. If you remember, you use this one. You use this QQ plot. QQ plot. How we use it? Straight line imply normal. This one does it look approximately straight line? kind of, this one is not so bad. Alright? Sometimes it's subjective, I mean it, but it's okay to, if you think it's not, then you try to explain, maybe it's look kind of like below the line on this part, that's okay also. Alright? On this part, this one is not, because that a big chunk of this line that actually go below here is kind of curvy. Alright? But the key for all the tools is that there are many tools. This tool is that if you see it look approximately straight line, it implies that sample might come from normal distribution. That's the key. Meaning that in the exam, right, you have to talk about straight line or not. If it's about straight line, normal. If it's not about straight line, then not normal. It's just that. Alright? If you get what it means, it's okay. If you don't get it mean, just know how to use it. That's the tool. Sometimes the tool don't have to make sense. Just know how to use it. Alright? Same thing for histogram. If they ask about normal, then you talk about bell shape or not. Alright, just that. Alright, that's the whole thing. That's why I don't write. Okay? I'm not sure if you still keep your attention note or not. Alright? And this one, box plot. If you remember, below here, box plot, right? Same thing we have from A and we have from B. Alright? We have from A and we have from B. Alright, so remember, box plot give you 5 numbers summary, give you the minimum and sometimes outlier. Any data point that outside the plot is actually implied that it could be outlier. There are two kinds of outlier, the very small one, very large one. If you remember, outlier is a data point that doesn't belong to populations. Or sometimes you might think should be excluded or not. Alright? So minimum Q1, median Q3, and maximum. Alright, so basically box plot is actually help you to compare distribution by comparing 5 numbers. Most of the time, the easiest way would be just comparing the median. And spread, you might compare the range and IQR. Remember, the range is from maximum minus minimum. But this one, you see the range from this one is kind of larger than this one. Alright? Sometimes you can also compare the IQR. Alright, the IQR. Use IQR and range to compare by which one is spreader or not. Like this one is seem like a little bit spreader than this one. Something like that. Alright? So that's about the box plot. Alright? Same thing, you see that these two they kind of show that there's a trend that maybe A is doing better, but still not a big obvious. Alright? And the point estimation, I'll put one right here. Alright? I'll put one right here.
This class was our first Asia Pacific team. Historical time. Now there's too many trade wars. Xi Jinping is causing too many troubles. It's gone.
To China's left.
Yeah. Alright? You see, this one is a sample size 40 and 60. Alright? And this one is a sample mean X bar. Right? X bar give you some kind of sample estimation for the location or the central value. Alright? You use X bar to estimate the population mean. Keep in mind, when we deal with stats, right? Most of the numbers that you see is actually come from the sample. And we use sample, the value from the sample to estimate the value from the population. You have to be very clear what is wrong from some sample or population. We never have population, but we try to conclude on population. Alright? So based on this, X bar from A is somewhat a little bit larger. So maybe there is some kind of trend that's saying that A is larger or not. Alright, but keep in mind the bad thing about the point estimation is that it's lack confidence. Alright, you can use the judgment. If the thing is large, then you try to say that this is a lot larger than that. If the thing is not, then you say that these two are somewhat similar. How do we know? Depending on situation. Alright, same thing on this side, we have standard deviation. Alright, so this is a sample standard deviation from A and B. Right, same thing, you can always compare larger Larger, smaller, or different? Alright? So you see that it's different that this one is a bit larger, but not so obvious. Alright? And also on this side, this is something that we talked about from last time also, standard errors. Standard error is estimates of SD of estimator. In this case is X bar. So it's estimate SD of X bar. I mean, it's a little bit harder to use, but we know what it means. You can use it, but you don't get it. Maybe you can just skip that. Never mind. But this too, you have to be able to tell. It's about center value. It's about spread. Right? One sample t-test, right? Now you see. Remember we talked about that. There are 3 levels of how to make conclusion or decision on population. First is by using the point estimation. Let's say, my question is that, can we say A is better than B? Simple question that I talk in pre-course, right? Can we say A is better than B? Better mean have higher score. Alright? So now the question is that, well, is the mean of A is greater than mean of B? Right? A than B is same thing as how to say that the mean of A is it larger than mean of B? Alright? So based on this point to point estimator, would you say yes or no? Yes or no? Yes, because this one is larger than that. You can also say no, that you say that this one is not so much larger than that one. Okay, I don't mind. This one is kind of great, okay? Because it's only larger by one something point. Alright? Next part, right? Next part on this part is actually, see, when this one is 0, then we only focus on the confidence interval. The confidence interval. This one is 95% confidence intervals. Alright? So when you look at the interval, you have to remind yourself each interval is for estimating what? Alright? So this one is for mu A. And this one is for mu B. Alright, this one is for mu A, this one is for mu B. Alright, and it comes with 95% confidence. Alright, based on this interval, I can ask anything. Alright, for example, can I say that on average, A get about 15 points? Yes or no? Based on this interval, can I say that department A get about 15 points? Quiet mean what? My question, can we say mu of A is equal to 15? Yes. How do we know that? The interval includes 50, so it could be 50. Are you confident on your answer? 95% confident. It's just that. You see? Right? Can we say that the mean of A is larger than 50? Can we say that the mean of A is larger than 50? No, because some part of that is smaller. There's some part of that is conflict. When you want to claim something, most of them, all of them have to back up that claim. Confident? 95%. Can we say that on average, A is larger than 13.85? Can we say that on average, A is larger than 13.85? Yes. Every single one in this interval is larger than 13.85. See? That's how you explain. One answer is part of the point in exam, but explanation is the thing that I'm looking for. Because when you do that research, it's not just the answer popping up. Everything has to come from somewhere. Alright, explanation is very important. Alright, okay, alright. So if based on this, if you say that the mean of A is larger than 13.85, can we say that A is better than B? See? Based on this, you conclude that A is larger than 13.85. is it kind of valid to say that A is greater than B? It is, but not absolutely, but it's still not valid somehow. If you assume that B is 13.85 and A is larger, then you can say A is better. But it's not the best approach. Okay, but it's still valid at some point. Okay, something like that. Alright. Now come back in here. Now you have one from A for A. This is for B. Alright. Now you compare these two intervals. Can, based on these two intervals, can we say that A and B perform differently? Perform differently mean what? Mean are different, right? So your question means like, are these two different? Right? If these two are different, mean that these two intervals should not be overlapping. Overlapping means some part of that could be the same. Alright, same whole thing. Alright, but if you don't get this concept, you will see more of the content into and get confused as well. Alright, so these two, you see, when you compare these two, are they overlapping? Yes, they overlapping imply that they could be the same. Alright, they could be the same, they're not different. It's not okay to say A is better than B, B is better than A. Alright? You see that if you use different approach, it could lead to different answers. Alright? Point to point, subjective. Alright? Interval to point, you can say A is better. It's still valid. I'm not saying it's the best one, but still valid. Alright? Interval to interval, they are overlapping. You cannot say A is better. Alright? Alright? As long as you stay with the two, whatever is said is just lead to one answer. That's a key for step. But sometimes 1, 2 is better than the other two. Yeah? Right? So that's a confident interval. Are they coming back? Output 3, right? Output 3, right? Output 3 is actually, you see that this one, right? This one, now the test value is changing to 13.85, right? 13.85, all right? And then this one is actually for one sample. All right? Now we talk about hypothesis testing. Alright? When you talk about hypothesis testing, the thing that you have to look for is p-values. Alright? In this output, where is the p-values? Remember? You need to like. ทำอะไรมาดูหมดเบี้ยวหมดแรง That's a p-value. You see was 6, right? So this part is p-values, right? This part is p-value. Whenever you see the output 6, significant, think of p-value, all right? Most of the time, the p-value from the software that you're going to use is two-sided. If you remember, two-sided is equal sign compared to not equal sign. Alright, and then one-sided is less than sign or greater than sign. Alright, so this one, when you see the p-value, don't use it yet. Alright, you have to ask yourself, this p-value is for what H0 and for what HA. Alright, so this one you see, when you see hypothesis, right? If you go back to the sheet that is summarized, one sample CH or TS, right? See? One sample t-test of the mean, equal sign put on here, not equal sign put on this one here. Alright? And that one in that table is compared to 13.85. So you put, this is the number that you have to compare. Alright? But in output, you see it's compared to 13.85. Alright? Your H0, your HA is mu equal to 13.85. Mu is not equal to 13.85. By the way, this is a mu of A from department A. Alright? So now, you see, you know this, based on this, is compared to this number. You see, if you don't know what's going on, it's very hard to extract information from the output. Don't even talk about how to make the output. Okay, alright? So now, we have this p-value. And now, based on this, we have this hypothesis testing, S0 and HA. Alright? How do we use p-values? Reject S0 when p-value is small compared to significant level. Let's say alpha is 5%. Alright, let's say alpha is 5%. Alright, this one compared to 5%, smaller or larger?
Smaller.
Right? Smaller, reject S0. Alright, reject S0, so which one you pick? HA. So based on this, your conclusion would say that the mean of A is not equal to 13.85. Alright? Alright? That's what it says. We cannot say that A is equal to 13.85. But if we assume that the B has the mean of 13.85, can we say that A performs differently from B? Based on this result, you pick this one. And then 13.85 is the mean of B, right? Can we conclude that A performs differently from B? If they perform the same, the mean must be the same, right? If they perform differently, the score will be different. And now this one is different from B. So A performs differently from B. See? Yeah? Right? So if A performs differently, it could be that A performs better or A performs worse. Alright, how do we know? Just go back to here, you see. Larger, so A performs better. That's a quick way. Alright, the other way is to try to get the p-value for one-sided test. But the quick way is to check different or not. Different, then you find which one is larger, which one is small. Okay? So that's the whole thing there. Alright? Now let's talk about new things. นั่งเงินก็เงินไปเดี๋ยวก็กลับมานะครับนะมันก็จะมีตัวช่วยแรงกระตุ้นให้ตื่นเต้น
Very tired. What did you say? After what? Huh?
So first, now before, right? In pre-course, we learned about the test for one sample. Test for one sample, right? Now we're gonna move on when we're dealing with more samples, right? More samples, right? So the first thing, right? First thing you talk let's talk about when you have two samples, all right? When you have two samples, there are two kinds of two samples. The first one, independent samples, and the second one is when you have paired samples. Alright. For example, let me give you an example. When you think about when you want to see if the diet program is effective or not. Diet program, the goal for the diet program is to lose weight. Alright. Alright. So let's say that you have 50 people, and then you weight them before go through the program. You ask them about the weight before they go through the program. Alright. And then after they go through the program, and then you measure the weight again after the program. Alright? You start with 50 people, then you have the weight of before 50 people. Alright? And then you have the weight after. So you have two samples, the weight before and weight after. Are these two samples paired? Is it match pair? Yes. Because when they have from the same person before or after. Alright? When you want to see if when you say the program is effective, meaning that before, is it have to be larger or smaller than after? Effective mean before which one or after is larger? After larger, huh?
Before.
ได้โปรแกรม is to รู้สึกนะ right so before must be larger so my point is that when you talk about different before minus after minus before you have to be very clear which one minus which one because it could flip the result alright and you see that this one is pair alright let me ask you more compared to what we had before same person measure the weight before and measure the weight after. Alright? But now I change. I just ask some people, 50 people, that don't go through the program and ask for their weight. I have one group, 50 people, that never go through the program. Right? And then I ask 50 people that have been in the program. And then ask their weight. I have two sets, one that never been in the program. Another one, they have been in the program already and asked for the weight. And then I get the mean from the first group that have been in the program. And then the second group that have been in the program. Can I compare these two groups? Why not? You not do that, right? You can. But is it good or bad compared to the first scenario? Get my point, right? The first one from the same person before or after. The second one, we have two samples. One is from the people that have been in the program. Alright, and then you have another set that have been in the program. Alright, these two are they paired? No. Because they're totally different group. Right? My question is that can we compare the weight from the first group to second group? Still you can. But is it better or the same compared to the first one? First one is better because you compare from the same person. Alright, but it's still okay to compare because if for the people that have been in the program, if the weight is a lot smaller, then you can say the program might be effective. Alright, but you see that these two scenarios are not the same. One is a matched pair sample. The other one is what we call independent sample. The logic is if these two samples somehow they're not related in any way, they are not paired anyway. Alright? This is what we call independent sample. If these two scenarios are not the same, they need to be treated differently. Meaning that the two will be different. Two for pair sample and two for not pair sample will be different formula. Alright? So my point is that if it's paired and then you use independent formula, it's wrong. This thing happened like for PhD student, they do have samples paired, but he's done everything in independent, fail. Have to share everything, result is wrong. Same thing could happen for IS. You know what I mean, right? If you ask the most recent batch for in this program, there's someone have failed the IS. One of the committee. Okay, all right. When it's not good enough, your committee cannot let it slide. All right, and part of that is doing research. All right, okay. Just say how serious it is. Okay, all right. So let's see, right? So first thing is that you have to be identified whether it's paired or not. All right. Let's take a look at the first one. Weight of samples of 15 marathon runners were taken before and after. You have 15 runners. You measure the weight before and after. Alright, they are matched pair by the same runners. Right? First sample is before, 15 of them. The second sample is after, and they match by the same runner. So they are pair sample. You see, when it's pair samples, sample size for both samples are the same, have to be the same. Alright? And in the setting, it will say that somehow is matching up by something. In this one, it's matched by runners. In my exam, I always ask This is pair sample. Why? Because it's very simple question, but it's the most important one. All right. Next one. Right. Random sample of 200 freshmen and 200 new transfer students. At university were given 50 question tests on current event to test whether the level of knowledge of current event differ for new freshmen and transfer students. You see, there are two sets of samples, one from new freshmen, 200 of them, and another set from new transfer students. Right? Do you see anything that says these two are related at all? No. When you cannot see the sign that they somehow match or pair, all right? They are independent samples. All right? Or you say that, well, maybe these two sets, they are not overlap. There cannot be one person that in the same one. All right? But if in different case, if you have a twins, one of twin in this group, another in this group that are paired. All right? If you have like couples, husband and wife, husband can only have one wife. Right? Right? Let's say normally, in normal case, legally, right? So let's say you randomly pick one, put husband in the end, then put wife in the end, then it could be paired. That could be paired because they are matched by couple. All right? But this one they're not, right? And keep in mind that when they are independent sample, the sample size don't have to be the same. I said don't have to be. It could be the same, but it could be different. So one key is that if the sample size are different, you can say they are not paired. Right? Okay, so that. Right? Last one, right? 60 students were matched by initial pulse rate. Each one measure the pulse rate. Right? And then the top two, right? With the two with the highest match up a pair. The third one, the fourth one, match up another pair. The fifth one, the sixth one match up another pair. So each pair they actually forming the people who have about the same pulse rate, right? And then for each one, right? One of students were randomly chosen to drink a caffeine beverage. Of the pair, you randomly pick one of the pair, have caffeine. Alright, or maybe Red Bull. Okay, and then the other one just drink water. Alright, so now their pulse rate will measure 10 minutes later to test whether the caffeine consumption elevates pulse rate or not. Okay, alright, you see that you start with something that is not pair, but you form a pair by having the people with about the same pulse rate. Okay, and then half of the group will be having a caffeine beverage, and the other one will have caffeine beverage. All right, these are pair sample because they are matched by pulse rate. That's the keyword. Right? Because you have this is a match pair sample because they are matched by pulse rate. All right, that's the keyword there. Right? So keep that in mind, right? Let's see. So maybe let's take a look at the easy one. But let's take a look at this one. You have this sample, right? I told you it's going to be a lot faster than because you have already have all foundation. It's just more like reading and using output, right? So let's see. Problem one, right? Problem one, right? Many people use scanner to read documents, okay, and store them in Word or some other software, right? To help determine which brand of scanner to buy, a student conducts a experiment wherein each document are scanned by each of two scanners. You have scanner A, you have scanner B. You want to compare which scanner is better or worse, all right? And he records the number of errors made by each. So what we have here, we have 8 documents. Alright, and that 8 documents are scanned by scanner A and also scanner B. Okay, all right, and then after the scan, right, they actually count how many errors happen from the scanning. All right, so the data are number of errors from a document that have been scanned. So the number is large. Large is good or bad?
Bad.
Bad, because you have higher number of errors. Alright? So the scanner that is better supposed to have smaller number of errors. Larger number imply worse. Okay? Okay, right? So now the data is like this. Just focus on the first two rows. Alright? Now is a sample one. Alright? This is sample 2 from B. Alright? The first column is implied that these data are from document 1. These data are from document 2. These data are from document 3. Alright? Are these two sample match pair samples? Yes or no? Yes, because
Use the same document.
they are matched by the same document. See, just that. Alright? So this one, this is pair samples. These are matched pair samples. Because they are matched by same A document. Right, something like that. Okay, so that's a key. Alright, it's important now here because if you don't know it's match pair, you might use the wrong formula. Alright, that part of that. Alright, so before I jump into the formula thing, right? Let's talk about this first, right? So you see, you have two samples. Right? When you have sample A, you can also extract the mean of A. You can get the sample standard of A, right? So by the mean of A and mean of B, based on these two, this is by using the point estimation, right? Alright? So based on these two, which one is better? A, because the mean is smaller. Is it smaller with significant? Is the difference significant at all? What do you think? Different by about 5 number of errors. I think that's a lot, right? Right? Okay. So that part of how we use the point estimation. Same old thing, same old logic. All right. Next, they are pair, right? They are pair, right? So when you have pair, you can find different from each pair. Right? Now different is defined as A minus B. A minus B. Good, right? If this number is small, A good or A bad? A good, right? Because smaller is better, less number of errors, right? So now we have different from each pair, right? So this one is a sample of difference, right? Even though you start with 2 samples, now it's not summarized to just 1 sample of difference, all right? When you talk about difference, you have to be very clear which one minus this one. Yeah, all right? And then you have difference. Then you find the mean of difference. Mean of difference, all right? Now we have this number. Then you can also get the S from difference. Based on this number, can you say that A is better than B? An explanation would be because the mean of difference is smaller than 0, implying that A has less number of errors than B on average. You see, the difficult is explaining same whole thing, right? If you still struggle with math, I'm sorry. But math is all around this program. Okay, it's just have to go over that already, right? So now you see my point. Now the new thing is that you have pair, you can have difference from each pair. And then you start with pair sample, you summarize to mean of difference. Okay, now let me talk about concept first. Alright? When you talk about pair samples, you have something like this. You have x1, x2, up to xk. You have y1, y2, up to y. Keep in mind that now the samples are in pair. Right? They are in pair. Right? When you talk about pair sample, what you care is the difference, which is x1 minus y1. d2 equal to d1 minus y2. Sorry. And then up to the n minus equal to xn minus yn. You see, the key is for each pair, even though you start with 2 samples, you summarize to just 1 sample of difference. Alright? And then from this d, you summarize to d bar. Alright? D bar is basically just d1 plus d2 up to dn dy by n. Same logic, right? And this one is for estimate mu sub d, right? This one is basically mean of differences. The mean of difference, right? It's the mean of difference because you find differences first and then you find the mean of that. Now you see, your main goal is to make decision on this mean. Only one mean of difference. So whatever apply on one sample t-test for one mean is going to apply on this, but on differences. Alright, so meaning that your S0, so this one is actually called pair sample t-test for mu sub d. Alright, so S0 is basically going to be mu sub d compared to mu 0. HA would be mu sub d. Let me change that to d0 here. This one will be less than sign, greater than sign, not equal sign, and d sub 0. Alright? Conditions are basically the same for one sample t-test, but now apply on differences. Alright? The first one would be random pair. Alright? The second one would be the population of differences are from normal, or number of pair is larger than 30. Right? It's not a new thing. Just think of one sample t-test on differences. Just that. See? Remember, just one case. Explain that. Alright? You see, random pair means what? We can talk about document. You randomly choose document and then you scan on board. If your pair is a couple, husband and wife, you have to randomly choose a couple. Not from the husband, not from the wife, from the couples. Something like that. Alright? How do we check normal? We have to find difference first and then make histogram of difference. If histogram looks normal, then it looks bell-shaped. QQ plot going to be applied on differences. Okay? Alright? And after that, you will have confidence interval for differences. Mean of difference, you can do the test on the mean of difference. Okay? Any question? คนมันยังไม่ตื่นเลยขึ้นเรียนวันแรกใช่ไหมไปเที่ยวเยอะนิดนึงครับผู้ชายรู้ว่าขึ้นนะครับ Now let's take a look. Now right now we have a new name. Pair sample t-test is a package for the mean of difference. Only work for pair sample on quantitative. Alright? And then this is how we set up S0 and HA. Same old thing, it's just the mean of differences. And then we have the condition. Alright? Now, let's take a look at output, right? Maybe let's take a look at this one first. The one that I just wrote is basically this one. If you get what I wrote on that, it's just that. See? You get, this is just D bar. Alright, right? And then you use D bar to estimate the mean of difference. By the way, if you read some textbook in Thai, sometimes they write it wrong. They write the mean of 1 as mean of 2. No, this is by different words than by the mean. So let you know. Alright, there are some Thai book that most Thai books are wrong. Assumption, you see, random pair. Alright, and then same thing is that D bar we go to normal when the population of different are normal or n is large, that's why. And then that's why we have this, and then we have the test. But let's take a look at output. This one is just the detailed one. Alright, so if you take a look at output in that sheet, right, you flip on this page. This is whole thing. Alright? You have, let's see, you have S equal to 0 here, right? When you see this one, S equal to 0, you think of the confidence interval. Alright? Let's see. Alright? See, this one, brand A, brand B, and brand A minus B. Alright? Same old thing, right? When you see at the log of the confidence interval, ask yourself, each confidence interval is for estimating what? The first one is for brand A. Second one is for brand B. The last one is A minus B. Alright? Based on these two, can we say that A is better than B? Based on these two.
Yeah.
Yes, because yes. Yes, if A is better to B, A must be smaller. Are they overlapping? They're overlapping. Say overlapping based on these two. You cannot say A is better, right? But it's not. Theoretically, it's not okay to you to do that because these two are not independent. So the interval itself is not independent in a way. Because they bad. But if you're going to use it, the same logic still apply. Overlapping about the same. Not overlapping, they are different. You know? Alright? How about last one? Last one is to estimate the mean of A minus B. Can we say that A is better than B based on the last interval? Yes or no?
Yes.
Yes, because all the values in the interval is smaller than 0. Imply that A on average has a smaller number of errors than B. Okay? I'll write it down for you, but right now I just want you to follow and try to think. Okay? Because if you write, you will think. Can you do that at the same time? It's hard if you don't. Alright, so that's the interval. See, same thing happened, right? So next, this is a new thing, right? You see this one is same pair. Alright? It's the same pair, right? So this one is called pair sample t-test. For mu sub d. Alright, sub d. But you have to be very careful. D of D difference is what? Difference right now we say A minus B. So in this case, D is mean A minus B. right? So now from this one, right? From this one, now it's a test. What we have to look for is a significant level, right? I mean p-values. P-value is right here. You see, p-value is right here. Okay. So this is your p-values. And you see, this is p-value. It's still t-test, right? P-values. How do we use it? Before you use it, you need to know what is S0, what is HA. Alright? Right now, we talk about mean of difference. Turn out that by default, for the software that you're going to use is always compared to 0. Two sides equal to 0 versus not equal to 0. So S0 would be mu of A minus B equal to 0. HA would be mu of A minus B not equal to 0. Right? By default, the output always do equal sign, not equal sign, compared to 0. Amen? Alright? Let's say alpha equal to 1%. Alpha 1%. Huh? This one is large or small? Compared to 1%. This one is larger. Which one you pick?
A.
The top one. Right? Reject when p-value is small. That's only the key part there. Remember that. Alright? So this one is large, not reject. Pick the top one. Top one, can we say that A is better than B? No. If the difference is 0 on average, they are about the same. Right? If alpha is 5%, large or small? Small. Small, huh? Right? Small, which one you pick? This one. Right? So A different from B. That's what it's literally saying, right? A different from B. Alright? If you want to know which one is better, maybe you can just look at the mean. Alright? I think the mean A is smaller, right? A is smaller, and B is larger, so A is better. Something like that. This is simple logic. Meaning that you don't get this logic, it would be bad. Yeah? But it's not so hard, right? You try it out, right? So that, alright? Sometimes, right? Let's see. Remember how in this one, if you talk about T here, right? Your T is right here. So T is equal to minus 3.225. This is 3.225. These two areas are adding up to this degree. If you remember. That's what we mean by two-sided. T is minus 3.25 of that. And then if it's two-sided, you have another side. You can, if you want one-sided, remember you start from T. If HA is lesser sign, you talk about area on the left-hand side. If you talk about greater sign on HA, area on right-hand side. Okay, the technical thing. So that's about that. I mean, if you don't get it, go back to review the old one and the new one. They go together. Alright? Meaning that if you get it together. If you get you mess up our own. Right? The other part of that. So that's about the p-value, right? In this one, you also have this one. So this one is say 95% confident for the different or mean of difference. So remember, when you want to use the interval, ask yourself, interval is for estimating what? Now we talk about pair. So it's going to be the mean of difference. In this case, A minus B. Alright? So this one is basically just for estimating mean of A minus B. Alright? Based on this interval, can we conclude that A is better than B? Yes or no? Yes, because number in interval is negative number. By the way, this one and this one are practically the same. Different by only rounding. See? This one is what? It's a one sample confidence interval from on different, which is split to same thing. That's why it's the same. Right? But by the way, anyway, this one, right? You see, on negative implies that the mean of difference is negative. So on average, A has less number of error than B. Okay? Right? Can I claim that on average, A make errors less number at least one error than B. Small, less number than B at least one errors. Yes, because you see it's starting from negative one something. See? That's something that you try to pass over the B, you know. Well, at the end, at least on average, you actually make one less error than B, something like that. Okay? You see, simple logic. Okay? So that's how we use that, right? This test and this interval require, sometimes I may ask for check condition. Right? The condition for one for pair t test. First one, random pair. Do we have random pair? Go back to setting. Alright? Setting, do they say anything about choosing randomly 8 document? Just say choose 8 document. It doesn't say random, so we don't know. So we assume. Same old thing, if I ask to check, you check condition, we have to check it, assume or given. Keep B blank, minus 1 point. Okay, conditions are serious because if conditions are not fine, the risk that you expect could be more. Right? And the second one is that right now you see number of pair is actually based on 8 documents. Number of pair is 8. Sample size is not large enough. All right. So you require that samples the difference are from normal or not. QQ plot. This one based on brand A only. Okay. This one based on brand B only. This one based on A minus B. All right. So if we want to check for pair sample, this one. All right. The condition have to check on the difference. Last one. Alright? So this one, does it look approximately straight line?
Sure.
Yes. Alright, so this one look approximately straight line. So the condition that the population from the difference are from normal are fine. Yeah. So let me go over the question one by one. Happy. Using the result in the table above without any additional calculation. Keep in mind in exam they say without any additional calculation, don't try to add more. Alright? Can be inferred that brand A is more, which is the more one is better than brand B. Alright? So in B it asks you to use the output from up here. Right? What kind of thing we have to compare? The mean. Alright? So one way is you can compare these two. Right? Or you can use this one right away. Doesn't matter. Alright? So this one maybe, let's say you have x bar A equal to 21.9, right? Which is less than 26.6, right? Which is equal to x bar B. Alright, so this one is implied that mu of A is less than mu of B. Alright, or you can use that one option. Another option would be x bar of A minus B equal to minus 4.8, imply that mean of A minus B is less than 0. So both imply that A is better than B. Something like that. Any question? See, same whole logic. Alright, if you want to say that they're not different, then you have to convince that these two numbers are not big difference, similar. Right? Or if you want to say that they're not different, then you have to convince that this one is a little bit different from zero. Right? Part C, right? Use the result in output A1.1. Alright? Infer if brand A is better than brand B. Alright? A1.1. Right? A1.1 is basically this one. Right? So the key part from A1.1, just like I circle here, right? Right now I circle for you, right? But in the exam, there will be a bunch of output, more than you needed. And you have to choose, right? Okay, so now we have 3 confidence intervals. You have to choose which one you pick. Right? You can use by comparing these two, or you can just use that one. I don't care. All right, just pick comparable first two or the last one. All right, and you see that you pick the first two compared to the last one, they give the different result. All right, just pick them and then just go with them. All right. So if I'll write down both of them. All right. So let's see. First option, right, it will be by comparing, say, 95% confidence interval for mu of A is 70.26 to 36.48 or 9. Alright, 95% confidence interval for mu of B is 19.46. 33.79. These two are overlapping. So mu A is about mu B. Right? This is also saying that mu A is not less than mu B. Right? The second option would be that 95% confidence interval for mu A minus B is minus 8.2 B to minus 1.27. This is all less than 0. Imply that mu A minus B is less than 0. So the top one, A is not better than B. And this one implies A is better than B. Right? So let's come back a little bit, right? I mean, if you get what it means, it helps to do this correctly. If you don't get, just learn how to use it. What step is follow step? It only leads to one answer. You see that? That's why step is useful. It's actually made to end the argument. Okay. Just to avoid being subjective based on the criteria that you choose. Okay. At the time there are too many approaches. That's all. Right? Yes.
In exam, we have to write down the two options or just choose one.
Pick one.
Pick one.
Pick one. Like in this one, because I asked you to use A1.1. So in A1.1, there are two possible ways to pick. Just pick one approach, pick way down. Yeah, sometimes I might not give you all three. Okay. Part D. Use the result in output A1.2 to answer to infer if brand A is better than B. Now is A2.2, A1.2, sorry. A1.2 is basically this one, you see? Yeah. You see from A1, Y2, there are two outputs that you can talk about. This one, or this one. Yeah? You can either use the interval or p-values. Alright? I will tell you. If you can use, if there is an interval, use interval. Interval is always easier to use. Unless I say find me the p-value. Sometimes I do that. Okay? Alright, but if there is option open, then if there both of them, interval is always better. Alright, so let's do that. Right? Same question. Is A is better than B? Alright? So one thing is that you have to be very clear is that if you see that in this one it doesn't specify significant level. When it doesn't specify significant level, you can use interval. But if it does specify significant level, you have to find the p-values. Okay? Alright? So let's see, right? From this one, right? First option is that 95% confidence interval for mu A minus B is, right? Is minus 8.23 to minus 1.27, all right? Or negative, right? Imply that mu of A minus mu of B is less than 0. So A is better than B. Number 2, point 1. There are two of them. This one okay, This one is basically the same as before. Because interval turned out to be the same one. Alright? Now if we use the test, right? So based on that one, S0 P mu of A minus B equal to 0. HA would be mu of A minus B not equal to 0. P values is equal to 0.015. You see the question does not give you alpha. If it doesn't give you alpha, you pick your own. Good start would be 5%. Or you can pick 1%, 10%, I don't care. Because in your real life, you have to pick for yourself. That's why sometimes I keep it open. Right? So let's pick alpha equal to 5%. Alright? So this one less than or equal to 0.05, which is alpha. So reject S0. Alright? So this one end up with mu A minus B not equal to 0. You see, based on this one, you can only tell A and B are not the same. We're not done. You want to say A is better. Alright? So with that, with x bar A equal to, with x bar A minus B equal to minus 4.8, which is less than 0, then we can say that mu of A minus B less than 0. Follow that? I have this one adding up. Because if they are different, one of them, it has to be either more than 0 or less than 0. So incorporate with the result. This one is negative. So not equal to 0 means have to be negative. So that's why I lead to that. See, using test can be difficult. More than difficult than that one. And with that, you can lead to the same conclusion, right? So this one you will get A is better than B at significant level of 5%. Remember, if you make a conclusion on test, always include at what significant level. Without that, 1 point off. Because change of alpha can change the conclusion. Okay? If it's not coming back, it's coming back fast, then what you're going to form. But if you worry, this kind of cycle gonna be repeat over and over and over and over and over. Okay? Any question คุณถามครับใช้ถามไหมครับ Have question ask now นะ This is when you don't want to find the new p-value. If you want to get the p-value for one-sided test, you can also do it. Alright, let's do that. That's why I put this one. See, if I put star, 2 star with point 2, right? So S0 would be that mu A minus B. We want to test that A is smaller than B or not, right? A better be is smaller than B or not, right? So on this one would be greater or equal to 0. HA would be mu of A minus B is less than 0. Okay? This one means A is better. This one means A is not better. Alright? So to get the p-value, draw a picture. Right? And then from the output, your t is minus 3.225. Right? This one, t equal to minus 3.225. And area on left or right hand side? Left or right? Left hand side. Left hand side. Alright? So it's this one. Alright? So your p-value, remember, when you do one-sided test, the p-value could be the smaller one or larger one. The smaller one is going to be half the size of two-sided. Alright? So if two-sided is 0.015, half of that would be 0.0075. Right? Something like that. But if it's larger one, it has to be 1 minus 0.0075. That's the thing that we learned in the pre-course. Alright, if you like that, you can just use up here. Okay, that's better. Alright, so in this one, meaning that the p-values is equal to 0.015 divided by 2, which is 0.0075, which is less than or equal to alpha. So reject S0 and then lead to the same thing here. Okay? I think we discussed about this that using point estimation is lack confidence. Right? Using the confidence interval is very flexible. Using the hypothesis testing is not flexible and sometimes we get lost along the way. Right? Any question? คุณถามไหมเริ่มถามเลยคือเขาบอกเปิดเทอมแล้วนะ Yes
What difference between X bar and mu?
X bar is sample mean. Mu is from population. When you write down S0 and HA, it have to be mu. Whenever you write down X bar, I'll take out point. Because SR hypothesis have to be statement of population. Alright? You see this one when I write down this, right? This one is from sample. We use this one to estimate this one. Okay? You see step 8 is very straightforward if you know what it means, right? It's not that tricky compared to probability. Right? But most of the time it's tough to, when you see this question, do you know, are we talking about pair, independent or one sample? Let me wrap up this question and then take a break. Part E, use result output 2.1, 2.2, 2.3 to check if condition to use the result in 1.1 A 1.1 and A 1.2. Alright? So now the question is basically asked for the condition. Alright? So now go back a bit, right? Go back a bit. Let's take a look at A1.1. A1.1, you have three output. The interval from A, the interval from B, and A minus B. So these three require the condition for one sample t-test for A, for B, and A minus B. One sample t-test, how many conditions? 2. First one, random sample. Second one, is the sample from normal or the sample size is large? Are the sample size large?
No.
No, only 8. Right? So, are sample random? The question don't say. So, assume A is random, B is random, A minus B is also random. Alright? How can we know it's normal or not? We actually look at 2.1. From 2.1 is for A. It's look approximately straight line. This is for B. Right? It's approximately straight line. This is for A minus B. Yeah? Alright? I'll come back to write it down, right? And for A1.2, A1.2 is for pair t-test. Right? Pair t-test has two conditions. It's a one sample t-test on pair. First one, random pair. Right? Okay. Second one, difference are from normal or number of pairs is large. Number of pairs is not large. So basically, you talk about random pair and last one. Yeah. All right. So basically, you talk about A alone, B alone, and A minus B. Yeah. So that's how. Let's see. How would I write it? Right? So the first one now pretty much the same because it's based on age document. Random sample A, assume, we all assume because it doesn't say random. From B, assume. From random pair, that's that. Because the difference is that now we talk about pair. Alright? And second one, right? This one is based on A2.1 QQ plot is approximately straight line. So samples A is from normal population. Right? Because we have to talk about this graph right here for A. Right? Now, similarly, right? So based on A2.2 QQ plot is approximately straight line. Sample B is from normal pop. Normal pop. And similarly for the last one, 2 based on A2.3 QQ plot is approximately straight line. Samples of A minus B is from normal of. I know it's a lot of writing, but that's how you write a research. Right? Because when you do research, you write research for someone else, not for yourself. Right? Because you know answer, you don't have to prove to anyone. Right? But when you write report, you want people to believe what you believe. Right? Just like that. So when the question like this, make sure you pinpoint what output are you looking at, because in the output there are 3 QQ blocks. You have to be very clear which one is for which one. Right? Because if you match up with the wrong one, it means that you're looking at the wrong output. That is bad. Right? So let's take a break.